video, I'm going to be talking about how tumors, they change macrophages so that they support and help out the tumor. So basically, macrophages are turned into TAMs. That's short for tumor-associated macrophages. And the way tumors do that is that they secrete adenosine and then creating the CD39 CD73 pathway. So macrophages have A2A and A2B receptors, and then the adenosine binds to those receptors, changing the macrophages into pro-tumor M2 phenotype macrophages that support the tumor. This also ends up reducing T cell counts and strength, because once the macrophage turns into an M2 phenotype, uh, the result is increased VEGF. So that's short for blood vessel growth on tumors. Also, reduced antigen presentation. Basically, that means that the APCs, or antigen presenting cells, they cannot train naive T cells to fight cancer cells, because T cells need APCs to train them. This is why it's important to fix a iron deficiency, as well as to avoid lysosomal membrane peroxidation, because hypoxia as a result of iron deficiency actually is one of the strongest macrophage reprogramming pressures. Also, macrophages, they when they encounter low oxygen, they upregulate arginase 1, and that ARG1 suppresses T cells. So tumors, they also release IL-10, TGF-beta, CSF1, PGE2, and lactate. So these are basically cytokines that push macrophages towards a pro-tumor phenotype. Okay, I'm going to be focusing mostly on PGE2 and also what fruits could help reduce PGE2. So first, PGE2 is derived from arachidonic acid via COX enzymes. So suppresses T cell function. Also, as I said before, promotes M2 phenotype, which supports and protects the tumor. Okay, so the first one here is oranges. One of my favorites has high vitamin C and hesperidin, so may reduce PGE2. Therefore, it's less likely that macrophages will protect or support the tumor. Also, vitamin C helps keep iron in a bioavailable state. That way, with the lysosomal membrane, if it's not peroxidized, the iron is able to be metabolized for the red blood cells to be able to provide oxygen to the tissues, reducing hypoxia. It's critical to reduce hypoxia because hypoxia is one of the strongest drivers that turns the macrophages to protect the tumor with an M2 phenotype. So oranges is probably one of the top fruits here for anti-cancer benefits. The next one here is grapes, and grapes helps reduce TGF-beta and IL-10. That's critical for T cells to be able to proliferate, because IL-10 suppresses antigen presentation, or in other words, will not let antigen presenting cells train naive T cells. So grapes are great for naive T cells to be trained, because grapes suppresses IL-10. So that suppressing IL-10, thanks to grapes, will allow APCs to train naive T cells. Also, in some tumor models, studies have demonstrated that grapes reduces TGF-beta, therefore reducing angiogenesis. Angiogenesis is the growth of red blood vessels that cancer cells and tumors grow off of and thrive on. And grapes also inhibits NFKB on CD27, CD70 axis, therefore preventing the exhaustion of T cells, because once it gets to that point, it's difficult to revive T cells, especially if chromatin is closed or shut. Okay, next one is apples. Now this one is a quercetin rich, so that means that uh, apples can help support your zinc levels because quercetin is an ionophore for zinc. So quercetin helps transport and shuttle zinc to where it needs to go, therefore preventing a zinc deficiency that could really weaken and dismantle the immune system. And that can be bad enough, or what could make it even worse is a macrophage M2 phenotype supporting the tumor and suppressing T cells. So apples with quercetin are a good way to help mitigate, or at least to attenuate, or to make less worse the macrophages supporting uh, tumors if the zinc is also helping boost the immune system. Okay, so the next one is to target PGE2, which is maybe the main focus of this whole video, because by reducing PGE2, that shifts away, or is supposed to stop or prevent macrophages from supporting tumors. And mango suppresses COX2 or COX2. Uh, by suppressing that COX2, it also suppresses PGE2, therefore not allowing the M2 phenotype where the macrophage supports the tumor. Next one also reduces PGE2, and that is tomatoes. Tomatoes are rich in lycopene or lysopene, or however you want to pronounce it. So tomatoes inhibit COX2, therefore also inhibiting PGE2, and not allowing macrophages to support the tumor. Next one is one of my favorite ones, and I talk about it a lot in my other videos, and that is pineapple. Pineapple is a protease fruit with a cleaving effect. So pineapple is unique compared to the other fruits because the other fruits, they don't have a cleaving effect the way that pineapple does, and pineapple reduces TGF beta, therefore also um, reducing the M2 phenotype state that leads to macrophages supporting tumors. Next here is a kiwi. Just like oranges, very high in vitamin C. So supporting a bioavailable iron to provide iron to red blood cells so that red blood cells can deliver oxygen around the body, because low hypoxia is low oxygen, and hypoxia is one of the strongest drivers of macrophages supporting tumors. Okay, so the effects of all of these fruits, they all aim or target the PGE2 with the main goal of taking macrophages away from an M2 phenotype that supports tumors, but it's mostly preventative or supportive. The effects of these fruits are strongest as part of an anti-inflammatory diet, which I could do some other videos on. I've also done an anti-exosome diet video, as well as an anti-CD27, CD70 diet video, so you can check those out if you want. So that's it for the video. Subscribe if you want more future videos, because I have many more coming. Also, share this video with anyone that might need them, and keep it locked in here on my channel, and I'll see you in the next video.